Question 5, you might have done something very similar in class, and we've got this piece of square piece of paper here, and it's 20 centimeters wide, so I've written 20 there, and we're cutting off a little corner off each one. We're cutting off x off here and x off here. So the first bit of thinking that you need to know is that from there to there is 20, take away the two x's. And because it's a square, the other direction there is 20 take away 2x as well. There to there is 20 take away 2x as well. When we fold it up, the whole volume is going to be 20 take away 20 take away 2x's for there to there, times by 20 take away 2x from there to there, times by x. And we're going to need to multiply that out. So 20 times 20 is 400. I've got minus 2 times 40. I've got minus 2 times 20 is minus 40x's, and there'll be another minus 40x's as well. And plus 2x times 2x, which is 4x squared. And that's all being times by x as well. And so the volume that we finally get is the thing in the question, the 400x minus the 80x squared plus the 4x cubed. As it's to show that, you might want to do an extra line of working in here just to make sure that you didn't just make that bit there up. Well, as it's a differentiation sheet, we're going to differentiate, but why are we doing that? Well, it's because we're being asked to find the maximum again. The maximum is when the gradient is 0, so let's differentiate this and find out what happens when it equals 0. We get 400 minus 160x plus 12x squared. We want that equals 0, so that's right, 0 equals. And before we try and work all that out, let's divide it all by 4, because 4 goes into each of those. So I'm going to get 3x squared minus 40x's plus 100. Quadratic, factorizes to 3x and x, it must do, because 3x squared, that's all it'll give. And 100, well, simple guess would be 10 times 10, wouldn't it? And you'd be right. So we've got two possible answers. From this one here is x is 10. And from this one here, we've got x is 10 over 3. So one of those is going to be our maximum, and one of those is going to be our minimum. We perhaps should find the second derivative to try and check it, but if you think about cutting 10 centimeters off each end, if you cut 10 centimeters off this side and 10 centimeters off that side, there'd be nothing left at all. So that one there clearly is the minimum, and this one here must be the maximum. Well, we then have to find out what the maximum volume is, and if you remember, the volume formula was this one up here. So we're going to do 20 take away 10 over 3 times 2 squared times by 10 over 3. Bit of fraction work to play with. You can try and work it all out, but it turns out to be 16,000 over 27 centimeters cubed. And yes, you can do that without a calculator.